Rahim. My name is Naz Ali, and today our topic of study is mechanical properties of advanced materials. Concepts include size dependent properties of nanoparticles. Then we study some interaction forces which include van der Waals forces, electrostatic forces, capillary forces, solvation, structural and hydration forces. Hardness and elastic modulus of nanoparticles, movement of nanoparticles, and nanoparticles in coating. First of all, we study the size dependent properties of nanoparticles. As we know, the nanoparticles are those which are microscopic with one dimension at least in 100 nanometer. The size dependent properties of the nanoparticles is basically because of the large surface area of the nanoparticles. The physical properties of the nanoparticles are quite different from their bulk variety. Now we study some forces including interaction forces and basic theories about them. As we decrease in size, we see some interesting problems arises in the mechanical properties of the nanoparticles. First problem arises due to the van der Waals forces. These type of forces are of three types. One is orientation forces, induction forces and dispersion forces. Orientation forces are due to the complete dipole of two particles. Induction forces are due to like induction by one dipole onto the other particle. And third is the dispersion forces. The dispersion forces are same as like as London dispersion forces. These forces cause attraction between the identical materials and repulsion between the dissimilar materials in the third medium like water. Now we study electrostatic forces and electrical double layer forces. On the surface of a liquid, the charged is present due to the three basic reasons. First is the ionization or dissociation of the surface groups into ions. Secondly is the adsorption or binding of the ions in the solution to the uncharged surface. Third is the because of the dissimilar surfaces interaction, the charge hoop across the surfaces of each other. A double layer is formed to neutralize the charged surface, which causes electrokinetic potential between the surface and any point in the mass of suspension liquid. Third is capillary forces. Capillary forces are due to the meniscus, are also known as meniscus forces. Capillary forces can be classified into two types: normal capillary forces and lateral capillary forces. These capillary forces are studied in powders, solids, and granular materials. The normal capillary forces is due to two actions. One is the pressure difference across the curved interface. Other is the action of the surface tension force exerted around the annulus of the meniscus. When we take any liquid into the and into the capillary tube, we observe a curved surface or a curved end of the liquid. This is known as meniscus. The tension created around that meniscus is due to the capillary forces. Origin of laterally capillary forces: larger the interfacial deformation, stronger the capillary interaction between them, the larger the deformation occur. These lateral capillary forces are very effective in controlling the colloidal particles and protein macromolecules which are confined in the liquid films to form fine microstructures. Now we study the other factors like solvation, structural and hydration forces. The forces can be in the form of monotically repulsive, monotically attractive, and oscillatory. These forces arise between two particles or surfaces if the solvent or water molecule are ordered by the surface. The solvation forces depend not only on the properties of liquid medium but also on the surface psychological psychochemical properties. So these forces are produced due to the following reasons, including hydrophilicity, roughness, crystalline state, homogeneity, rigidity, and surface microtextures. The hydration force is a strong short range repulsive force between the polar surface separated by a thin liquid layer, and these can be decayed as the thickness of the layer increases. These hydration forces help us to determine the behavior of diverse system, which includes colloidal dispersion stability and swallowing of clays and biological membranes. Now we study some properties including hardness and elastic modulus of nanoparticles. The nanoparticles hardness and elastic modulus often diverge from their bulk materials as we studied earlier, and they are over size dependent behavior. These behaviors can be classified into three basic categories. So we study the first category. In the case of spherical polymer nanoparticles, these are yet not uniform size dependent behaviors of the mechanical properties. Means in category 1 we study spherical polymer nanoparticles, although the size dependent behavior is not uniform. Next is the summary, which represents some sizes, hardness of bulk materials, and their some properties. So here we will compare an example of nanoparticle with its bulk particle. For example, we study the property of compressive moduli of polystyrene nanoparticle. We studied that it is a slightly less than the corresponding bulk material, and its reason is because of the presence of hydrated ionic functional group. The elastic modulus of polypropylene nanoparticles was higher than that of the bulk material. It was thought that the glass transition temperature Tg, the crystalline phase and crystallinity etc., could affect the deformation of the polymer chain inside and thereby results in the change of the particle elastic modulus. Now we study the second category for crystalline metal nanoparticles. Okay, in crystalline nanoparticles, as we know that in crystalline structure, there is no delocalization, but delocalization inside the particles has demonstrated a factor contributing to the change in mechanical behavior of nanoparticles, which is against the traditional view. For silicon nanoparticles, if we take the example of silicon, it was observed that their hardness was 4 times greater than that of their bulk silicon. Apart from delocalization or defects, the change of the lattice strain and the bond energies of nanoparticle to the compressive strain and were proposed as another cause of them strengthening and weakening of the mechanical properties of their. Now we study the third category for nanowires or nanotubes. It has been typically found that the elastic modulus of silver and lead nanowires decrease with increased radial diameter. Means as the radial diameter of the lead or silver nanowires decrease, its elastic modulus increase. The increase in the modulus was attributed to the effect of surface strain, the oxidation layer, and surface roughness or the surface tension effect on the fracture properties rather than the elastic behavior of zinc oxide. Nanowires are affected by the surface effect due to the presence of surface cracks and defects. Worth mentioning is the fact that measuring the mechanical properties of the individual nanoparticles is very complex. Many influencing factors could affect the finally measured result. The factors which affect the results are mainly included the uniform dispersion, precision location of particles, application of load onto the particles, measurement of the minimum particle deformation, many uncertainties including instrumental calibration and calculation modulus. Movement of nanoparticles. Various factors such as gravitational factor, surface forces, viscous flow forces, and the forces due to the Bowman's motion results in the movement of nanoparticles in the medium in different ways. Up to now, several methods have been used for making high resolution measurements of the motion of the single nanoparticle. There are many factors which affect the study of the movement of the nanoparticles, which includes complex forces, mediums, and environments. Nanoparticles in coating. There are two main categories of nanoparticles which are summarized. So, first of all, we study type 1. In these, coating ceramics including aluminium oxide, titanium oxide, silicon carbide, and carbon based graphite and nanoparticles are usually added. These are the reasons that certain particles are using in reinforcement to enhance the hardness of water resistance or companies. The high hardness and strength of particles, migration and disclosure motion of grain boundaries can prevent the particles in the matrix, heterogeneous nucleation effect of particles in metal and metal alloys. These are the different reasons due to which we added the nanoparticles into the bulk material for getting a high quality product result. Second type is the modification of the physical properties of the polymer matrix can be achieved by adding inorganic or organic nanoparticles, causing some new characteristics of polymer to be obtained. But some are things which are very important for this, like uniform dispersion of nanoparticles in the matrix is very crucial in obtaining improved mechanical properties of nanocomposite coating, since the maximum fluid content of nanoparticle with the large surface area is limited. When the content of nanoparticle in the nanocomposite coating exceed a critical value, particles agglomerate would happen, resulting in determination of the mechanical properties, decrease in Young modulus, and increase in the wear rate. Thank you.